أعزائي طلبة وطلبات شهادة الثانوية العامة رياضيات، أهلا بكم. النهاردة إن شاء الله هناخد درس جديد في الجبر اسمه نظرية ديموفوار. طبعا احنا عارفين نظرية ديموفوار هي تعميم لنظرية ذات الحدين. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson in algebra. It's titled Demoivre theorem. Dear student, look at introduction about Demoivre theorem. The first, graphical representation of complex number argand plane. Dear student, look at example. When represent each of the following: z1 3 plus 2i, z2 2 minus 3i. Look at, we have x-axis and y-axis. Z1 means take 3 units in x-axis, 2i take 2 units from y-axis. This complex number. Z2 2 minus 3i, take 2 from x-axis and 3 from negative y-axis. Z1 is 3 and 2i take 3 in x-axis, 2 in y-axis, 2 negative 3i, z2 take 2 from x-axis, negative 3 from y-axis. Look at, dear student, represent z equals 3 minus 2i and its additive inverse. What is additive inverse of z? Excellent student. Additive inverse means change the sign of two terms, negative 3 plus 2i. Look at, dear student, when represent z negative 3 negative 2i, look at the solution. Z equals 3 minus 2i and represent its additive inverse is negative 3 plus 2i. Look at x-axis, z is 3 negative 2, 3 on x, negative 2 on y. This complex number, dear student, contains real number and imaginary number. What is the real? 3. What is the imaginary? Negative 2. Look at negative 3 plus 2i, take negative 3 in x-axis and 2 in y-axis. Look at, dear student, z1 and z2 is image of its additive inverse by origin point, reflection on origin point, or rotation by O, or center, its center, origin point, and positive or negative 180, its angle of rotation. The 2 points represent the numbers and additive inverse are symmetry with respect to the origin point. Then they are ends of a line segment for which the origin point is midpoint of between 2 points. Means, dear student, any complex and additive inverse is reflection or additive inverse. Origin point is midpoint between 2 ends of line segment. Example. How to represent z and z bar? Z bar, it's conjugate of complex number. We have z equals 3 plus 2i and z bar equals 3 minus 2i. Dear student, look at if we have complex number. What's the mean complex number? Complex number contains real number and imaginary number. If we have complex number and we want to find additive inverse, we change the two sign. Change the sign of real and change the sign of imaginary. But complex number, if we have complex number as x plus yi, it's conjugate x negative yi. Dear student, remember, any number of complex number multiplied by its conjugate equal real number. Then x plus yi, it's complex number. What is the conjugate x minus yi? Now we are represent the complex number and its additive inverse and its multiplicative or addition inverse of complex number if we have z equal x plus yi and conjugate equal x minus yi. Represent the complex number and its adjective. Z equals 3 plus 2i, conjugate equals 3 minus 2i. And write your notes. Look at 3 plus 2i. Take 3 from x and 2 from y. But z bar is 3 minus 2i. What is the notes? The notes in when represent z and z bar or z dash is imagine of z on, yes, x and student in x-axis by reflection on x-axis. Look at z bar and z and z bar. This is line segment to end z and z bar, but the midpoint 0.30 lie on x-axis. Another example. Change each of the following algebraic forms into trigonometric form. Dear student, if we have z equals complex number root 3 plus I and other one 1 minus root 3i, third one 3i minus 2, z equals negative 1 negative I. This complex number contains real and imaginary. What is the real of the first? Root 3. What is the imaginary? 1. Z equals 1 minus root 3i. What is the real x? What is the imaginary? X equals 1. Imaginary equals negative root 3. Z equals 3i minus 2 minus 3. Then real equal negative 3, but imaginary is 3. Z equals negative 1 negative I. What is the real? Negative 1. What is the imaginary? Negative 1. Look at the solution. At the first, look at, dear student, z equals root 3 plus I, x equals root 3, y equals 1. What is our x and student? Square root x power 2 plus y power 2. We find our square root 3 power 2, 3, 1 power 2, 1, square root 4 equals 2. Then r equals 2. Tan alpha y over x, absolute y over x equals 1 over root 3. What is the angle? Each tan 1 over root 3 x and student. We find alpha, shift tan 1 over root 3 by using calculator. Then alpha equal 30 degrees. Then we put theta equal 30 degrees. After that, z equals 2 multiply bracket cosine 30 degrees plus I sin 30 degrees. Dear student, this is complex number by trigonometric form. Another one, if we have z equals 1 minus root 3i, what is the x? x1. What is the y? Negative root 3. What is our x and student? Square root x power 2 plus y power 2 equals root 4 equals 2. Then r equals 2. What is the alpha? Tan alpha equals root 3. What is the alpha? Which tan equal root 3? X and student. We find shift tan root 3. Then alpha equals 60 degrees. Then we put z equals r is 2. R theta equals 360 degrees minus 60 equal 300. At the first, theta lie in the fourth square. Then z equals 2 cosine 300 degrees plus I sine 300 degrees. Number 3. Look at 3i minus 3. This position lie on second square. Remember, we have 4 quadrant. First quadrant, positive, positive, negative, positive in second, negative, negative in third, positive, negative in fourth. At the first, z equals 3i minus 3. What is the x? Equals 3. What is the y? Negative 3. Square root x power 2 plus y power 2 equal root 18 equals what? Root 18 equals 3 root 2. What is the alpha? Tan alpha. 3 over 3 equals 1. What is the alpha? Which tan equals 1? 45. Then alpha equals 45 degrees. Then we put z equals theta equals 180 minus 45 Why? Because theta lie in the second quad. Second quad, it's end 180. 180 minus 45 equal 135. Remember, z equals r 3 root 2 multiply cosine 135 degrees plus I sine 135 degrees. Number 4, z equals negative 1, negative I. What you notice? Z equal negative, negative, coefficient of x, coefficient of y, negative in third quad. Then, remember, theta lie in the third quad. Remember, we find the r, square root, coefficient of x power 2 plus coefficient of y power 2 equals root 2. R equals root 2. What is alpha? Yes, tan alpha equals 1. But 1 is tan alpha. What is alpha? Alpha equal shift tan 1 by using calculator equal also 45. Remember, dear student, alpha lie in third quad. Then theta equals 180 minus 4 plus 45 equals 225. Why? Because theta lie in third quad. 180 plus 45 equal 225. Z equals root 2 cosine 225 plus I sine 225. Dear student, very important values. Study these values. 1 equals, we can put 1 cosine 0 plus I sine 0 degrees. I cosine 90 plus I sine 90. Negative 1 equals cosine 180 degrees plus I sine 180 degrees. Negative I equal cosine 270 plus I sine 270 degrees. Dear student, these important rules. 1 equal, we can put 1 as trigonometry. Cosine 0 plus I sine 0. I cosine 90 degrees plus I sine 90. Why? Because cosine 90 equals 0, but sine 90 equals 1. We can put 1 as complex number by trigonometric form. 1 equal cosine 0 plus I sine 0. Why? Because cosine 0 is 1, but sine 0 equals 0. We can put 1 as complex number, the first real cosine 0, the second imagine I sine 0. I cosine 90 plus I sine 90. Why? Because cosine 90 also equals 0, but sine 90 equals 1. We can form I as trigonometric form as cosine 90 plus I sine 90. Also, dear student, we can put negative 1 as cosine 180 plus I sine 180. Negative I cosine 270 plus I 270. Change into trigonometric form. Number A, negative 4, number B, 3i, number C, negative 2i. Solution. Negative 4 equals 4 times negative 1. 4 multiply, bracket contains cosine 180 plus I sine 180. We can put negative 1 cosine pi plus I sine pi. Number B, 3i. 3i means 3 times I. What is the I by trigonometric form? X and student. Cosine 90 plus I sine 90. What is the 3i? 3 multiply, bracket contains cosine pi over 2 plus I sine pi over 2. Negative 2i means equal to multiply negative I. What is the negative I? X and student. Cosine 270 plus I sine 270. By using pi, then 2 negative I times negative I means 2 multiply, bracket contains cosine 3 pi over 2 plus I sine 3 pi over 2. Another example. Modify each of the following. Z equal 4 cosine 30 plus I sine 30. Number B, Z equals 3 multiply, bracket contains negative cosine 60 plus I sine 60. Number C, Z equals negative 2 multiply cosine 300 plus I sine 300. Number D, Z equal cosine 120 minus I sine 120. Solution. Look at, dear student, we have theta equals 90 minus 30 in the first, number A equal 60 degrees, the first quad, then Z equal 4 cosine 60 plus I sine 60, theta equals number 2, number B, theta equals 180 minus 60, 120, then we put Z equals 3 cosine 120 plus I sine 120, number C, Z equals 2 multiply negative cosine 300 minus I sine 300, theta equals 180 plus 300 equals what? 480 equals equivalent 120. Then we put Z equals 2 multiply bracket contains cosine 120 plus I sine 120. Number D, theta equals 270 plus 120 equals 390 equivalent to what? 330 degrees. Why? Because 390 equivalent 30, 390 contains 360 plus 30. Then when find equivalent of 390, subtract 360 from 390 equals 30 degrees. Then we put Z equals cosine 30 plus I sine 30. We can solve by another solution. Z number A 4 multiply cosine equals 1 over 2 plus cosine 60 root 3 over 2i. Therefore, Z equals multiply bracket multiply 4 each term by 4 equal Z equals 2 plus 2 root 3i. What is R? Square root x power 2 plus y power 2 equals 4 plus 12 equal root 16 equals 4. Then we put theta equals 60 degrees, Z equal 4 cosine 60 plus I sine 60. Number B, Z equals 3 multiply negative 1 over 2 plus root 3 over 2i. Then Z equals negative 3 over 2 plus 3 root 3 over 2i. Then we find R, square root negative 3 power 2 plus square root 3 power 3 root 3 over 2 for all power 2 equals what? Equals 3. Then theta equals 180 minus 60 120, both Z by using R multiply cosine, then R equals 3 multiply cosine 120 plus I sine 120. Number C, Z equals negative 2 multiply 1 over 2 minus root 3 over 2i. What is R? Negative 2 times 1 over 2 equals negative 1. What is the imagine? Root 3i. You find the value of R by using x power 2 plus y power 2 under square root, then R equals 2. Then we put theta equals 180 minus 60 degrees equal 120. Then R equals R is 2 multiply bracket contains cosine 120 plus I sine 120. Number D, Z equals root 3 over 2 plus 1 over 2i. What is R? Square root 3 over 2 for all power 2 plus 1 over 2 power 2 equals square root 3 over 4 plus 1 over 4 equals 1. Then theta equals 30 degrees. We put Z as 1 multiply cosine 30 plus 1 multiply I sine 30. Then Z equals cosine 30 plus I sine 30. Important rules. Z1 equals R1 multiply cosine theta 1 plus I theta 1. If Z2 equals R2 multiply cosine theta 2 plus I sine theta 2. We have two complex number in trigonometric form. Then Z1 multiply Z2 equals R1 R2 cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. Then Z number 2, Z1 over Z2, when divided to complex number by trigonometric form, R1 over R2 multiply cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Now we are to translate into De Moivre theorem. Dear student, R multiply cosine theta plus I sine theta for all power n. This is important theorem. Equals R power n cosine n theta plus I sine n theta. R cosine theta plus I sine theta for all power 1 over k. Then we distribute 1 over k in R power 1 over k cosine theta plus 360 over k m plus I sine theta plus 360 m over k. M equals 0, 1, 2 and so on. K equals -1. Solve it problems. Number 1, z equals 2 multiply cosine 30 plus I sine 30. If we have complex number, its form 2 multiply cosine 30 plus I sine 30. Z2, 3 multiply cosine 60 plus I sine 60. Find each of Z1, Z2, or product of two complex number, Z1 over Z2, division of two complex number, Z1 for all power 5. Dear student, look at the solution. Number 1, Z1, Z2 means 2 multiply cosine 30 plus I sine 30 times 2 multiply cosine 60 plus I sine 60. Then Z1, Z2 equals 6 multiply cosine 90 plus I sine 90. This first required. Z1 over Z2 means R1 over R2 multiply cosine, yes, -30 plus I sine -30 by using the previous rule. Then equal 2/3. What is the cosine -30? Cosine -30, dear student, equivalent to cosine 300. Why? Because cosine -30 equal cosine 30. Also, sine -30 equal negative sine 30, but this angle lie on the fourth quadrant. Cosine 30 equivalent to cosine 330. Then Z1 over Z2 equal cosine 330 plus I sine 330. The second required. Number 3, Z1 for all power 5. By using De Moivre theorem, we have Z1 equals 2 multiply cosine 30 plus I sine 30 for all power 5. We distribute power 5 into R and cosine and sine. Then Z1 power 5 equals 32. Why? Because 2 power 5 equals 32. We multiply 5 multiply 30. Cosine 30 becomes cosine 150. Also sine 30 also equal sine 150. Third required. Now we are to translate to another example. If Z1 equals 2i, Z2 cosine pi over 4 plus I sine pi over 4. Remember, pi over 4 means 45 degrees. Cos pi equals 180 divided 4 equal 45. We have two complex numbers. The first number is 2i, has no real, but the second complex number Z2 by trigonometric function, trigonometric form. Trigonometric form cosine pi over 4 is real, but imagine I sine pi over 4. What is required? Find Z1 times Z2 for all power 4 in trigonometric form and algebraic form. Dear student, we have two forms, trigonometric form and algebraic form. Trigonometric form by cosine sine, but algebraic form by numbers. Solution. Z1 equals to I, then R equals 2. Why? Because X equals 1, but X equals 0, but Y equals 2. What is R? Square root X power 2 plus Y power 2. Then X equals 0, Y equals 2, 2 power 2 equals 4, square root 4 equals 2. Then R equals 2. What is the theta? Equal 30 degrees. Then we put Z1 as in trigonometric form. 2 is R multiply bracket contains cosine 90 plus I sine 90. Z1 times Z2 for all power 4. We Z1 2 cosine 90 plus I sine 90 times cosine 45 plus I sine 45 for all power 4. We distribute by using de Moivre theorem. Then Z1 times Z2 for all power 4 equals 2 multiply cosine, we add cosine 90 plus 45 equal cosine 135 plus I sine 135. By using de Moivre theorem, if we have bracket contains cosine 90 plus I sine 90 multiply bracket contains cosine 45 plus I sine 45. What you do, dear student? Yes, excellent student. We add 90 plus 45, then angle becomes 135. Also, sine 90, sine 45 becomes sine 135. Then Z1 times Z2 for all power 4 is 2 multiply cosine 135 plus I sine 135 for all power 4. We distribute power 4 it to 2 power 4 equals 16 times cosine 540 plus I sine 100 sine 540 degrees. Then Z1 times Z2 for all power 4 equals cosine 180. Why? Because 540 equivalent 180. By using 540 minus 360 equal 180 plus I sine 180 degrees. Dear student, remember cosine 540 is equals or equivalent cosine 180 because 540 more than 360. What is the equivalent? We subtract 540 minus 360, angle is 180 degrees. Then Z1 times Z2 for all power 4 equal 16 times cosine 180 degrees plus I sine 180 degrees. This algebraic form, 16 times negative 1 plus 0 equals negative 16. Dear student, I am very happy to spend such time with you. Remember, Moivre theorem is important theorem, is general of polynomial theorem. Dear student, don't forget math, symbol, think, work, produce. Goodbye.